Hello everyone, my name is Amanda Abakoff. My partner in this project is Jonathan Rivas. We're going to discuss the analytics behind Spotify. To give you a bit of an overview of our case study, we're going to go through the executive summary. We're going to discuss the problem that they faced. We're going to discuss each key challenge that contributed to the problem they were trying to solve. We're going to cover the solution that they found. We're going to cover how to implement that solution. And finally, we will discuss the possible other solutions that there are. So this is going to give you a little bit of an overview, the executive summary. Mainly, Spotify creates many playlists. I'm sure we all have Spotify, or at least have heard of it. I know many of us probably have that nice student deal that they have. Spotify creates playlists that are curated for users and artists. So you may have an artist playlist that is called This Is, and then it has the artist's name. That specifically covers all of the popular songs that artist has created and puts it in a playlist for you. Additionally, they make playlists for specific users. So it'll combine different genres and songs that you'll listen to into maybe your daily mixes that'll change often. You also have playlists at the end of the year that are curated specifically for your top music. So we're going to take the Spotify Web API and we're going to discuss and break apart the data that we found through there through visualizations and k-means clustering. The data has specifically 12 variables that we had to make up and that the case study had to make up and understand. These variables evaluate how the artist's popularity ranges. When we were performing the clustering, there were 6 specific clusters, and each cluster counts for each genre. We're going to go over the variables and the genres in a little bit. So let's discuss the artists that we evaluated. The data took the top artists for each of the 6 genres, and the case study took some of those artists from that data. So for pop music, we have artists like Taylor Swift, Ed Sheeran, Lana Del Rey. Hip hop covers Macklemore and Jay-Z. R&B focuses more on Bruno Mars and Stevie Wonder. EDM and house cover the Chainsmokers and Avicii and other artists similar to them. Rock covers both current rock and classic rock, so there's Coldplay and Elton John. And for jazz, we have Frank Sinatra and Norah Jones. There are many other artists that could have been used, but these were the main artists that were popular at the time. So let's discuss the problem. The problem this case study is trying to find a solution to is how does Spotify establish and evaluate what variables contribute to creating the Spotify Top 50 and even their other playlists. Specifically, we're going to focus on Spotify's Top 50. And to do so, we will need to understand all the variables that impact and create popularity for each artist. So, there were many key challenges, but the main key challenge was what are the variables. There are so many variables that contribute to the popularity of an artist or maybe the successfulness of them. Could be specific time of the year, it could be the sound. So in this case study, they broke it down into only 12 of the variables. These variables were specifically used to provide visualizations and clustering. The variables are, as you can see, danceability, energy, the key of the music, how loud it may be, the mode, how speechiness it is, the acousticness, instrumentalness, and the liveness, covers balance, tempo, and even the duration in the milliseconds. So, the solution. Jonathan is going to go in a little more depth soon. I'm going to cover a bit of an overview of the solution. The variables specifically are seen as features. The case study needed to use R coding in order to see how all of the features relate to each individual artist specifically. There were data frames made so that way it contains the artist and their songs. The case study used formulas that you can see on this slide to understand and extract the specific features from IDs as a vector.
Thank you, Amanda, for presenting the first half of this presentation. My name is Jonathan Ribas. I'm presenting the second half. So further discussing the solution that the analyst used after the data was cleaned up and deciding the code program, which is all that he was using. The next section was to decide how to run a formula on each artist and create a vector in which it will create track IDs for each musician. So to do that, they created a code line called getFeatures, which, as stated before, features is another name for the variables being used in this analyst. So it performed the getFeatures on those vectors. After the data was merged to contain the features for all the tracks and the playlist for each musician, the analyst merged it with the mean of each feature. And that was used in an aggregate function. So on the bottom left, you'll see the code used for the getFeatures. And on the bottom right, you'll see the end result for the mean, in which you could see for about 10 artists looking through the variables right there. So after that data was received, now it comes to visualizing it. One of the biggest jobs for analysts is to be able to convey the data in a way that people could understand. Most people can't understand code. Most people can't understand all these aggregates and functions that are performed. So that's why visualization is such a huge piece in performing for analytics. So this analyst performed two visual charts. The first one's a radar chart. We didn't go that over this semester, but I think it's actually a pretty awesome chart. So I'm starting off with radar charts. This chart's used to kind of compare the vibes of the musicians with the features / variables that was discussed in previous slides. And this was done by using R as well. So looking at that code line, you'll see the mean features norm function, which will apply the mean to the features. Once he applied that for all the artists, he then ran the code, and on the bottom, you'll see the line code to create the chart radar. So this is the visualization for the radar chart. It's definitely bright compared to our charts, and it may seem kind of confusing in the beginning. but let me explain it for a minute. All the features are on the outer rim of the presentation, such as danceability, energy, key, loudness. And then in this chart, the analysts did it by 10 artists at a time. So if we look at Taylor Swift's and Drake's music, you can see that their music heavily relies on danceability and mode. Mode is another way to say if it's a major key or a minor key. But then if you look at an artist like Kygo, who's a DJ, instrumentalist is a big part of their music. And then for a lyricist like Kendrick Lamar, obviously the liveliness and speechiness is a huge portion of their music. And if you listen to music and you think about those artists, you could tell that this data truly correlates to these artists. So moving forward, the second visualization and algorithm that the analysts performed was a cluster analysis. This is one of the latest analysis we've actually done in class, so it's really cool to see that it was performed and something that interests me and Amanda. So just a little bit review again what cluster analysis is. It's to divide into groups on similarities in the data. So in this case, it's grouped by music preference and then also by grouping the artists into clusters. So the first thing that needs to be accomplished is rescaling the data. Rescaling data is important because, like in class, you could see that a bunch of like the columns, the numbers might be quite different. And if the numbers are quite different in the columns, you definitely get very inaccurate data. So the first thing the analyst did, which is cool because obviously we didn't do coding in this class, so seeing the coding code for something that we did through Excel is pretty cool. So how they scaled the data was by running the code scale.features. And then he did it by doing the row names and finding the mean of the features for the musician. So going on to the next slide is deciding what clustering the analysts use. So K-means clustering was the one decided. It is one of the most popular techniques for unsupervised statistical learning. It works interactively to assign each data point to a K group based on the variables. In this data set, it was K equals 6. It was the 6 represents the top 6 music genres that we have today. Below, you can see the code that this analyst used. So you could see, pull the library from all of the code that he used before, made a plot for it, loaded it all in, and then on the bottom you can see a little code line that says K means underscore plot. That is the way that he displayed the visualization for the K-means clustering. So here's the K-means clustering visualization. At first, it's like, whoa, it's a kind of a hard thing to see. But on the right, you could see that each genre was color-coded per genre for the 6 genres. And looking at the colors, you could see that most genres usually stayed with each other, whether it's green on the right and blue on top, or pink and orange. But you can also see that there is some kind of in between certain genres. Some genres do have a mixture of artists who use different types of genres. So you could see an artist like Kendrick Lamar be not too far from Maroon 5 because they both have some music that has like a pop beat in it. So if you look more closer to this presentation, you can see how closely a lot of these artists are correlated, but they, in terms of their top genres seem to be in their top genre, which is awesome. Like I stated before, if you know these artists and you know the genre that they're usually in, you can see it correlates pretty well and pretty much agreeable with most people think. Some outliers are Coldplay. You can see on the bottom, more to the right, slightly to the right. They are a rock band, but you could tell that they're in so many different features. It was hard for the model to tell because they have songs with Beyonce and rappers and all that stuff. So there are definitely some outliers. So in conclusion, like I said, if you know an artist, you should pretty much tell that they were properly put into the right genre category. So you can see Kendrick Lamar and Kanye West and Lil Wayne, all these rappers in the um, number 6. So that means all the rappers together. But you'll see another rapper, Wiz Khalifa, in 4. That's because he has quite a bit of pop hits with other pop artists. But one of the most interesting groupings I've seen, and thinking about it, it somewhat makes more sense, but if you could see on number 3 is Post Malone is put as number 3. But if you go 3 people over to the right, you'll also see that Adele is number 3. So when you think about it, these are completely 3 different artists in terms of vocal range, and you may consider their music completely different. But if you think about the instrumentals, how the music's created, and more of the math of the music and the science of the music, and you go more into that, you might be surprised to see how similar these 2 artists are in terms of that. So overall, this clustering seems to work proper, but there are some surprises, like I said, with Post Malone and Adele. So hope you all have a great day. This is our presentation, and thank you.